here we have the function natural log of a plus x minus natural log of a minus x divided by x. Now what we will do here is we are going to take a as the common factor from a plus x, so that leaves us with 1 plus x over a. Similarly, for the second term, we're going to take a as the common factor, which leaves us with 1 minus of x over a divided by x. So we have limit x approaching 0. So we'll now apply the property, and the log of a times b is going to be equals to log of a plus log of b. So we have natural log of a plus natural log of 1 plus x over a minus natural log of a minus natural log of 1 minus x over a. So the minus sign is appearing because it's multiplied to -1 here, divided by x. So we can cancel the log a, so that leaves us with limit x approaches 0 natural log of 1 plus x over a divided by x minus limit x approaches 0 natural log of, so we have 1 minus x over a, so what we'll do, we'll rewrite it as 1 plus negative x over a whole divided by x. Now we need x over a in the denominator, so we will divide x by a, so that means we'll need to multiply by a. Similarly, here we need negative x over a, so we're going to multiply it by negative 1 over a, so we'll need to multiply with negative a. So that gives us 1 over a times limit x approaches 0 the natural log of 1 plus x over a divided by x over a. So we have a negative a in the denominator, so that gets multiplied with the -1. So we have positive 1 over a times limit x approaching 0 natural log of 1 plus minus x over a divided by negative x over a. So we have 1 over a times 1, which is the definition of the logarithmic limit, plus 1 over a times 1. So we get 1 over a plus 1 over a is 2 over a. So this is going to be the limiting value of a given function. So we'll have 2 over a when x approaches 0. So this problem is similar to the previous one. Instead of a, we have the number 3. So we can solve it using the same method that we used in the previous problem, where for this particular case, I'm just going to replace a by 3. So this is going to be equals to 2 over a. So a here is 3, so answer will be 2/3. So that's it. Let's go and do another. And the limiting value of the similar function, log of 5 plus x minus log of 5 minus x over x, is going to be equals to 2 over a. So a here is 5, so we'll have 2 over 5. Let's do another problem. So here we have the function log of x minus log of a divided by x minus a. So we're going to combine the two terms in the numerator by using the property of log. So we have log of a minus log of b is equals to log of a over b. So our numerator will now become limit x approaching a, the natural log of x over a divided by x minus a. which will be equals to limit x tends to a. Now we know that the limit when x approaches 0, natural log of 1 plus x divided by x is going to be equals to 1. So we'll try to make our function equivalent to log of 1 plus x over x. So we have log of x plus a. So what we will do, we're going to add and subtract 1. So we have, let me take care of the parentheses here. So we are going to add and subtract 1 from it, such that we have 1 plus x over a minus 1. Now we take a as the common factor in the denominator, so that will give us x over a minus 1. Now a being a constant, we can take it out of the limit, so we have limit 1 over a times limit x approaching a, natural log of 1 plus x over a minus 1, this is a, whole divided by x over a minus 1. Now we're going to consider an x over a to be equals to y. We can take x over a minus 1. Let me rewrite it. X over a minus 1 to be equivalent to y, such that when, so this is an assumption, such that when x is equals to a implies y is equals to 0. So we get 1 over a limit y approaching 0. So we have natural log of 1 plus, so x over a minus 1 will become y, whole divided by y. Now this is the definition of the logarithmic limit, so its value is 1, so that gives us 1 over a. So the limiting value of log of x minus log of a divided by x minus a is going to be 1 over a when x approaches the value a. Let's do another problem. So here we have log of x minus log of 5 divided by x minus 5. We need to determine its limiting value when x approaches 5. So we can use the result from the previous problem. So there we had a. So we had natural log of x minus natural log of a divided by x minus a. The limiting value when x approaches a is 1 over a. So a here is 5, so we'll get 1 over 5. So this is going to be the limiting value of the given logarithmic limit. Let's go to the next question. So we have log of x minus 1 divided by x minus e. E is the exponent. So we need to find its limiting value when x approaches e. Now this problem is quite similar to the previous two problems. So we're going to use the result straight away. So but before that we need to change the numerator. So we have limit x approaching e, the exponent, log of x minus 1. Now we have 1, so that can be written as the natural log of a. So natural log of e is equals to 1. So as this replaced 1 by the natural log of e divided by x minus e. So the value is going to be 1 over a. So a here is e, so that means we'll have 1 over e. So this is going to be the value, limiting value of the given function when x approaches e. Let's go to the next question. So we have log of a plus x minus log of a divided by x. So we're going to use the property of logarithm and combine the two terms in the numerator. So that is going to give us the natural log of a plus x over a whole divided by x. And we have limit x approaching 0, natural log of a over a, which is going to be 1, plus x over a divided by x. So what we'll do, we'll consider the denominator x, and we're going to divide by a and then multiply the denominator with a. So that gives us 1 over a times limit x approaching 0, natural log of 1 plus x over a whole divided by x over a. So we have 1 over a times the definition of the logarithmic limit is 1. So our final answer is 1 over a. So let's move on to the next question. So here we have the natural log of 2 plus x plus log of 0.5 whole divided by x. Now what we will do, we'll work with the second term in the numerator. So that is natural log of 0.5. So 0.5 is natural log of 1 over 2. So we can use the property log of a over b is equals to log of a minus log of b. So we'll have natural log of 1 minus natural log of 2. Now natural log of 1, its value is 0 by definition. We have minus log of 2. So that means natural log of 0.5 is equals to negative times the natural log of 2. And for the first term in the numerator, so we'll take 2 as the common factor. So that leaves us with 1 plus x over 2. So we have the second term, so that will be negative log 2 whole divided by x. So we have limit x approaching 0. Now we have the product of 2 and 1 plus x over 2. So using the property of logarithm, we have log of 2 plus the natural log of 1 plus x over 2 minus log of 2 whole divided by x. So the log of 2 and negative log of 2 gets cancelled, leaving us with limit x approaching 0 natural log of 1 plus x over 2 whole divided by x. Now we need an x over 2 in the denominator in order to be able to apply the definition of the logarithmic limit. So we will divide the denominator x by 2 and then multiply the denominator by 2. So that leaves us with half limit x approaches 0 natural log of 1 plus x over 2 whole divided by x over 2. So we have half multiplied to 1. So our limiting value of the given function is going to be equals to half when x approaches 0.